everyone. We have already completed first 4 questions of our exercise 1. So now we start with 5th question. Okay, what is your 5th question? Check your page number 29 in your textbook. So that the function from R to R and fx equal to, function is given on real number fx equal to x cube and is injective. Injective means what you have to show? 1 1, only 1 1. So what is it? Let's start with f of x1 equal to f of x2. So x1 cube equal to x2 cube. Now taking cube root on both sides. So what is it? x1 cube raised to 1 by 3 power and x2 cube raised to 1 by 3 power. That means x1 and x2 is same. Okay, if this, then you can say it is a 1 1 function, or you can say injective. Clear? So this is the shortest one, 5th question. Now come to the 6th question. Sixth question is, give an example of our 2 functions. First is f n to z and g z to z such that g over f is injective, means 1 1, but g is not injective. In hint it is already given that consider the function fx is x and g of x is mod x. What is given? That you have to show g over f is injective, or you can say 1 1, but what you have to show? G is not injective, this one. Okay, so let's see. First we have to show that g over f is injective. So let's find g over f. G over f of x. So g of fx. Okay, if g of fx we are writing, so what is your fx? X only. And what is your gx? Mod of x. Okay, if your g over x is mod of x, then what you have to take? Natural numbers only, which is, remember, here it is given that function is mentioned from natural number. Now n to z you get, so you have to choose the natural numbers only. So when you choose g over f of 1, that will be 1, g over f of 2 will be 2, and so on, because we are choosing natural numbers only. So natural numbers start with 1. Okay, so from this single question, single answer, so your concept of injective is true, so proved. But g is not injective. So let's start with g. G given from z to z, so minus 2. Mod of minus 2 will be plus 2, and if I take g of 2, then mod of 2 will be 2 again. For 2 different question, 1 answer. So this function is many one. Many one means not injective. So when you combine g over f, you get mod of x. But why it is a injective or 1 1? Because now your g over f, when you write g over f, it starts from n to z. So when you choose the numbers from domain, because of its domain is n, it is a 1 1. But if here domain is z, then definitely g over f also not injective, remember. So it's based on what? Your sets which is given for domain and codomain. So I think this one is clear to you. Fx is given, gx is given, g over f we have shown that it is injective. Injective is 1 1, and g is not injective, because for 2 different questions we are getting the same answer. So concept of 1 1 is not satisfied here. So that's why you can say g over f injective and g is not injective. Okay, this is your 6th question. Now come to the 7th. Your 7th question is, again give an example, and which 2 functions are given? That is f again n to n, g also from n to n, and what is given? Such that g over f is on 2. G over f is on 2, but f is not on 2. Okay, in your hint, 2 things are given, that consider fx as x plus 1 and g of x as x minus 1 if x is more than 1. n equal to 1 if x equal to 1. Now see, what is the condition for onto? If you want to show onto, we have to check range and codomain. This should be same. If range and codomain is same, you can say it is onto. Okay, so let's start first combine g over f. Now when you want to combine g over f of x, we can write g of fx. Now check your fx. What is your fx? X plus 1. Now you have to consider this as x and put up here. So x plus 1 minus 1 means x. It is identity function and here 1. So we cannot make any change. So for g over f of x, you are getting identity. G over f is identity, and you know identity function is onto only. But f is not onto. Why f is not onto? Let's prove it. Let's start with natural number. First natural number 1. So x plus 1. 1 plus 1 will be 2. Second natural number 2. 2 plus 1 will be 3. Third natural number 3. 3 plus 1 will be 4, and so on. So when you find range of f, what is the range of f? It starts with 2, 3 up to so on, which is not equal to natural number because first natural number 1 is missing. So from this you can say it is not onto. But g over f we are getting identity, and definitely if you put up 1, 2, 3 and all, you get 1, 2, 3 and all only, because identity function itself are same function. So from this you can recognize that g over f is onto, but f is not onto. Now 8th question. In 8th question, given a non-empty set x, consider P of x, which is the set of all the subsets of x. What is defined the relation P of x as function for a subset A and B if in a P of x A related to B, if and only if A subset B is a equivalence relation. Justify your answer. Okay, now new topic, equivalence relation. Now question arises that what is equivalence relation? So for that we have to check 3 things: reflexive, second thing symmetric, and third thing transitivity. Okay, what is reflexive? We have already discussed that relation of terms with itself. Symmetric means suppose A related to B, then B related to A. Third transitive means A related to B, B related to C, then you can say A related to C. If all 3 properties are satisfied, then only your relation is said to be equivalence. Okay, so let's start with subset first. First for reflexive, you all know that set A is always subset of itself. In set theory, in your primary classes also, in your 11th standard also, you already learn that every set is a subset, null set is a subset of every set, and a set is a subset of itself. These things we already discussed in our previous classes. Okay, so first property already satisfied, that A is always subset of A, then relation of A with A itself means function, this relation is reflexive. Now question arises for symmetric. If I say A is subset B, so can we say B subset A? No. Why? Because let's take 2 elements 1, 2 in A. Now if I take B as a 1, 2, 3, so all the elements of A are in B, but the all elements of B is not in A. So this is not true. And if this one is true, A subset B, B subset A, if both one is satisfied, then you can say A and B equal, but here it is not mentioned, so it is not a symmetric. Okay, second property is not satisfied, means this relation is not equivalence. But let's for our convenience check the third condition also. Okay, if I take A subset B, what is the meaning of it? All the elements of A are in B. Now another relation I take, B subset C, means all the elements of B are in C. In the same example, let's take C, 1, 2, 3, 4. Now I can say A subset C because all the elements of A are in B, all the elements of B are in C, then all the elements of A is also in C. From this example only you can understand that 1, 2, 1, 2 and 1, 2 in C also. So it is transitive. So subset is always reflexive also and transitive also, but not symmetric. So but our condition is equivalence. So when it is one property is not satisfied, it is not a equivalence. But if question asks that check reflexive symmetric transitivity, then you can say it is reflexive and transitive but not symmetric. Okay. So this is the end of this question. Let's come to the ninth one. Ninth question based on the same concept. Read it. Given a non-empty set X, consider a binary operation. Which binary operation is mentioned? P of X cross P of X to P of X. This is the condition is given, and what is the relation? A related to B, that is A intersection B. Okay. P of X is the power set of X, so that X is the identity element for this operation and X is the only invertible element in P of X with respect to the operation. Okay, here identity. Again new topic. What we learn in binary operation? That if binary operation, if combining these two and if you get A only or combination of this equal to A, then E is called identity. Now before we start for identity, first let's check is it commutative and associative or not. That also you know. If I write A intersection B or B intersection A, meaning remains same. So in our 11th standard only we already learned that intersection is commutative also, associative also. So we start with identity. A intersection X equal to if I get A only, then what is it? Because X may be any another number. But if I get X intersection A also A only, then you can say X is the identity element. Okay, if A and B, if I intersect it and if I get X, then what you can say? A and B both are inverse of each other. But here what is your question? You have to show only one thing, that X is the identity element for this operation and only it is invertible. Invertible means identity is inverse is identity itself. So there is a no question of invertibility. Okay, now on 10th question. What is our 10th question? Check it. The number of all the onto functions for, this is the MCQ question. Set is given 1, 2, 3 to n, and onto with itself. Onto with itself means suppose you have n element, we have its formula only, n factorial onto relations you get. What is your n factorial? N minus 1, n minus 2 up to 1, means the product of 1 to n. This is your 10th question. Okay, let's discuss next question, 11th one. Let's set is given in 11th one, S equal to ABC. T is given 1, 2, 3. Find F inverse of the following function from S to T. For first one, what is the given thing? F is A comma 3, B comma 2 and C comma 1. And what is your second question? For F, A comma 2, B comma 1 and C comma 1. Okay, this way given. Now check first thing. First of all, to check inverse. What we have to check? If we check for inverse, then function should be 1, 1 and onto. So, when your S to T function is mentioned, so this is your domain, this is your codomain, right? Okay, now remember here, A is your question, 3 is your answer, B is your question, 2 is your answer, C with C 1. Single question, single answer. So what you can say, this function is first thing 1, 1. Okay, for onto what you want? Range and codomain is same. So what is the range here? 3, 2 and 1, and that is only your codomain also. So it is onto also. If your function is 1, 1 and onto both, then you can find its inverse. Okay, now we are finding inverse. How can you find the inverse of f? So f inverse equal to, now question became answer, answer became question. So we can write 3 comma A, 2 comma B and last 1 comma C. So this way you get f inverse. Now the same thing we have to repeat for what? Second question. So let's start with 1, 1 first. We are checking with A 2, B 1, C also 1. For two different questions, same answer. So you can say this function is not 1, 1. Now it is not onto also. Why not onto? Because for onto 1, 2, 3 we required as a range. But here range is 1 and 2 only. So range and codomain again not same. Function is not 1, 1 and onto. You cannot find inverse of it. Means this function is not invertible. So in first one it is 1, 1 and onto both. It is invertible. So we have find inverse. But the second is not 1, 1 and onto. So you have to write given function is not 1, 1 not onto. So it is not invertible and we cannot find the inverse of it. I think for this class we stop here because now only 7-8 question is remaining. So we can complete it in our next class. And in next class maybe we complete our chapter. So meanwhile you complete your notebooks. Main important thing in this chapter as per as board exam concerned, that we discuss it once. See what you have to remember. First, reflexive symmetric transitive, your first topic equivalence, that is too much important for JEE also and for MCQ also. Second topic you learn 1, 1 onto. 1, 1 onto type questions, 2 marks question can be asked because weightage of this chapter is more. From this chapter long question also there. So you have to prepare inverse also. Why inverse also? Because in inverse we are getting long questions. First we prove 1, 1, then we prove onto, and then we are finding is it invertible or not, and then we are finding inverse. Third thing you learn composition of a function. Composition of a function means we are combining two functions. Now inverse we learn by two methods, by which first we are proving 1, 1 and onto. By that method also we have find inverse. Second thing, by composition of a function also we find inverse. How we find for in composition? In composition, suppose we are combining two functions and you are getting identity, then we can say both functions are inverse of each other. That is your fourth topic. And last topic, binary operation we learn. In binary operations also, say middle two topics which are first is for MCQ important. Our binary operation is for long question also, for short question also. 1, 1 and onto also can be asked in MCQ also and for long question also. Inverse also can be asked in MCQ because according to your old weightage, your 6 or 7 MCQs may be there. So for that you have to prepare full chapters proper way. This chapter is too much important for JEE also. So I have completed every topic. Last binary operation, in that which method you learn 4 things: commutative, associative, identity and inverse. So you just do it, go through proper way. Whatever your doubt you can tell me on mobile. And our last few questions are remaining. You can try it at home also, but then again we complete it in our last class. Okay, so thank you very much.